Okay, we'll try a ranking problem for an alkene. Do. There we go. So let's take a look at this alkene, and we got to figure out if it's cis or trans. So the way to do that is we're going to divide the alkene in half, right down the middle. We're going to rank these two substituents off of this carbon right here to see who has a higher priority. Right? So the first thing we do, we look at it and say, okay, we go from here to here, we have a CH2. Here we have a CH2. Basically the same. No, not basically the same. They are the same. CH2, CH2. Go to here, we have a carbon, and here we have an oxygen. So who has higher priority, carbon or oxygen? Oxygen does, based on the fact that it has a higher atomic number. Right? So that means this group here has a higher priority at start. Good. Now let's look at the other one. We have a carbon and a carbon. This is a carbon with a hydrogen, and a carbon that's bonded to a carbon and another carbon, right? We'd count the pi bond as 2 bonds to carbon. This carbon is bonded to a carbon, and a carbon. So which has higher priority here? The top, the terbutyl group, right? Because there's an H here, right? H has a lower atomic number than carbon. So the top here is going to have higher priority. So this molecule, this alkene is cis. Good. So the molecule is cis, but there's another important point to make here is that there's another alkene within our molecule. But this alkene has 2 H's. Because it has 2 H's, I can't differentiate between these two groups. Neither one takes higher priority. H and H are equal in priority. So this alkene right here is actually neither. So this cis belongs to this alkene, but this alkene right here actually is neither cis or trans, because we can't find a way to rank one of the groups higher on either side of the carbon. Okay, let's do an RS problem. So just make an sp3 hybridized atom with 3 different things on it. So let's put OH here, O-methyl here, there. There we go. 4 different groups on there.
Whoa, is that like the carbon coming out? Is that another carbon?
Oh, sorry. Let me fill that in a little bit. Yeah. It's just one. Okay. So, I have to rank these. Easy thing to usually do is find the lowest or the highest priorities right away, I think. So which one of these can we immediately say is going to be one of the higher priorities? Right? I would say the things with O's, right? We can, because these are carbon, carbon, oxygen, oxygen. The things with O's we should analyze first and compare them probably. This one's an O to H, O to carbon. Who has higher priority?
O to C.
O to C, so that's 1. That's a bad one.
11.
Up to 11.
We're going by atomic mass, not electronegativity.
Atomic number.
Yeah.
Atomic number, not atomic mass. Atomic number. So this oxygen over here is going to have to be 2 then, right? Now we're left to analyze carbon and carbon. CH, carbon bond to hydrogen and a carbon. Carbon bond to a hydrogen, a carbon, and a carbon. Which one has higher priority? The one that has, so carbon, carbon, wash. Carbon, hydrogen, wash. Carbon, hydrogen, carbon, carbon. So the carbon, carbon one has to have higher priority. 3, and that means this has to be 4.
Even though the first one has an oxygen somewhere.
Even though the fourth one has an oxygen somewhere, that we didn't get to it. So that's priority is ranking based on the row, right? So even though there's an oxygen here, this is still lower priority than these. This one. Yep.
Like raise like carbon.
So carbon,
Yeah.
carbon bond to carbon, carbon bond to carbon,
Yeah.
carbon bond to hydrogen, carbon bond to another carbon. This guy wins.
Okay.
So it doesn't matter there's an oxygen later on. That's why I kind of drew it that way.
Yeah.
Okay? So this is the first step. First thing you gotta do is rank these. Now at this point, I think the easiest thing to do is take out your model kits and just map your thing onto this. Right? So that you do your red, white, and blue. Right? Alright, so we go to our green is 4. Then we go red, 1, white, and blue is 3. So we got to map it onto that, and then we got to see what we got. All right, so this stereo center ends up being R.